Let's discuss this case. The case is used to help us understand how to represent multidimensional data by using Python two-dimensional list. Before we start the discussion, I assume you have already know how to initiate a Python two-dimensional list, as well as access the elements in a two-dimensional list. The case wants to find the closest pair in a two-dimensional coordinate. Given a set of points, each point is represented by two values, two numbers, one number for one dimension. Then we want to find the closest pair according to the distance. So we firstly need to define the distance, how to calculate the distance between every 2 points. Assume we have U and V, these 2 points, as well as their values. Then we use the most popular distance, Euclidean distance. In the Euclidean distance, we need to find the difference along every dimension. Then we take the square of the difference along each dimension, sum of them up, then take the square root. This is the Euclidean distance. Here the case is for two-dimensional space. The same distance formula can also be used for higher dimension. We just need to calculate these square terms for every dimension. Let's go over some background information. We know we will use Euclidean distance, which is based on the straight line between two dots. If we draw these two dots in x and y coordinates, and also we can draw the distance as a dotted line between two dots. The length of this dotted line in green is the Euclidean distance. If we know the values for U and V, we can substitute these x and y with the specific values. Then we can calculate how long this line is between two dots. This is the Euclidean distance. Here you see we will have one distance if we don't consider the direction. Without taking into the direction account, we only have one distance value for every two dots. If we take the direction, from red or blue, from blue to red, if we take this direction into account, we will have two distances. In this case, we don't consider the direction, so this distance will be symmetric. That means for every two dots, we only have one distance value. This is the two dots, the distance between two dots, we have one distance. Then here is a couple of examples showing you how to calculate the distance for the given two dots. Simply do substitution, then get this distance value. A Euclidean distance has these three properties. A distance is always non-negative because of this square root. and the distance is the symmetric. If we don't consider the direction, then the distance from A to B equals distance from B to A, and the distance to a dot to itself is 0. We have these three properties for Euclidean distance. Now here, if we have three dots, how many distances do we have in a three dots case? If we draw these three dots, we have red, green, and blue. Then we can connect these three dots. Every two dots in this three dots case, we can get these three straight lines. So that means in a case of three dots, we should have three distinct distance values when the order doesn't matter. That means we don't consider direction. We don't consider the order of the two dots in a distance. Then if we have a case of 8 points or 10 points, how many distinct distance values are there? In order to calculate the distinct distance values in a given set of points, we need to know combination, which is a math concept. We need to enumerate every two pairs for a given set of items. Then here we need to enumerate every combination of two items. Every time we pick two items from the given set of items, then how many combinations? We have two cases. Order matters, order doesn't matter. That means we don't consider the directions in each when we in terms of distance. In the first case, if order matters, that means first item, second item, because we will pull two items from the collection to make a pair. Then the order of these two items matters. Then how many combinations do we get if order matters? Here is the Python script. We have these four dots. Here we didn't use two-dimensional space. We just use these individual items. Say we have four items. You can also imagine you have four apples. You have four fruits. Then each time you need to pick two from these four items. How many different combinations do we have? So here we use 1, 2, 3, 4 to represent these four items, four distinct items. Then make a list, Python list dots. Then we need to list all the combinations. We use nested loop. The first loop will iterate the four items in order to pick up the first item. This will pick up the first item, right? Yeah. Then the inner loop will pick the second item. Then we will print first item and the second item in each iteration. So here we run the script. We can see the total combination is 4 times 4, which is 16. This is the first item. When we pick the first item, for example, we pick 1 as the first item, then we will pick the second item. Second item, we have 4 possibilities because we have 4 items. So we combine first item with every of the 4 items. As a second item, we get the 4 combinations. Then for each of the item, we repeat the same combination. Therefore, we get 4 times 4, 16 combinations in total. So this is the number of the combinations when order matters, because you can see here we have 2 items consisting of 1 and 2, these 2 items. We will treat this combination different from 2 and 1. We also have this combination. 2 is the first item, 1 is the second item. In this case, we will treat 1 and 2, 2 and 1, these 2 as 2 distinct combinations when the order matters. The second case is if we don't consider the order, how many combinations regardless of the order. That means 1 and 2, 2 and 1, these 2 combinations will be treated the same. They are identical. We only need to keep 1, either 1 and 2 or 2 and 1. So we don't need to include both. So in the second case, we just need to make one modification here. We will first get the total number of iterms, put that into a variable n, okay? Then in this script, we will iterate, we will use index as the iterator instead of the item. So we will iterate over the range of the indexes. Then the difference is in the inner loop, when we pick the second item, right, to make a pair, we don't start from the beginning, from the index 0. Instead, we start from the index I. I is the current iterate in the first out loop, which is the index of the first item, right, in the current iteration. So we start from the current, right, index of the first item. Then we will not repeat combining the same items. So this is the modification. You just need to adjust the range in the inner loop when we pick the second item. So now if we print the combination regardless of the order of the 2 items, this time we will see we have reduced the combinations from 16 to 10 pairs. Then noticeable, you can see for the first item, we need to combine the first item with every, right? Every of the 4 items, 1, 1, 1, 2, 1, 3, 1, 4. Then in the second item, right, in the second out repetition, we start from the index. We start from the second item. We start from the second item instead of the first item for the inner loop. So we get 2, 2, 2, 3, 2, 4. However, 2, 1 will not be included because 1 is index less than, or actually 0 with 0. 0 is the index less than the 1, which is the current one. So by this, we can eliminate the duplicate pairs when the order does not matter. When we calculate the distance, we don't need to consider the order because the distance is symmetric. So we should consider this case and also modify the range in the inner loop. And also, same time, we also should get rid of this distance to itself distance, because this distance will be 0. We don't need to exclude from this combination. However, when we want to find the closed pair, this we don't consider a dot to itself as a closed cell. So here, just take an example of 4 dots. We have these 4 dots. This time we take this two-dimensional points. We have 2 dots. We group these 4 dots into a Python 2-dimensional list. So it is a list. Then each item in this list is a list. So it's a list of lists. Each element represents 1 dot. Then we have these 4 elements in this 2-dimensional list. With these 4 dots, we first can enumerate all the pairs with the order method. Then we will have 4 by 4, 16 pairs. Now we can exclude the distance to itself, because it is always 0. We don't need to calculate. Then can reduce the pairs further to 12. So that means now we need to calculate 12 distances for these 4 dots. And next, we can apply the symmetric property to these distances. Then we can reduce the 4 pairs because we have 4 dots. A dot to itself is 0. Then we can, we apply the symmetric property of the distance, then actually can reduce the pairs only have the swapped positions of the same items. Then we can reduce these pairs by half. Then we will get 6 pairs. So that means in a case of 4 dots, we only need to calculate 4 distance values. Then we can find the closed pairs having the minimum distance. So here is a formula. If we have n dots, right? If we have n dots, n can be any integer. Then the total number of distinct distance values is calculated as n times n minus 1 divided by 2. So we can verify this. If we have 4 dots, then you substitute n with 4. 4 times 3 is 12. 12 divided by 2 is 6. So the 6 pairs. So this is a formula which tells us the distinct distance values we should calculate for a given set of n dots if we want to find all the distances, distinct distance values. Okay, so now before we write a Python script by using Python base library without any external library, I would like to show you this external library. However, we always want to study the programming by using the base library before we actually to take advantage of these advanced external libraries to speed up the computation as well as the development coding. So I will first showing you how will be a distance matrix look like. Yeah, because we have pairs if we list each dot in horizontally and also each dot vertically, then we can generate a grid, right? A grid of 4 columns and 4 rows, which can also refer to as a matrix, right? 4 by 4 matrix. Then each cell in this grid or matrix is the distance, right, from one dot to another. Okay, so here if we write this dot by their index, then the index is 0, 1, 2, 3, and also vertically, right? Then by rows, we also have this dot 0, 1, 2, 3. Then if we read the value from the first cell, this value is the distance, Euclidean distance, from dot 0 to dot 0. That's the first dot in the list. So a dot to itself, distance is 0. Then if we look at this cell, if we look at all the cells diagonal, right, all these diagonal cells, they are 0 because all the values on the diagonal line is the distance of a dot to itself, so they are all 0. Okay, and if we look at this matrix, this cell is the distance from dot 0 to dot 1, and we see the distance is symmetric. Now if we look at this cell is the distance from dot 1 to dot 0. You just need to find the column and the row index. That gives you the 2 items. This distance is between. So noticeable, this distance is the same as this distance because simply they are just the same distance between 2 items. The 2 items is 0 and 1, or 1 to 0. So this is the same pair if we don't consider the positions orders. So if we look at this matrix, you will see the upper triangle. This is the upper triangle, right? This makes the upper triangle, and this part makes the lower triangle, lower part of the matrix. You will see the upper part and the lower part, right? The upper right corner and the lower left corner, they are identical. So this matrix is symmetric. And also, this actually just confirm what we say. We only need to calculate this amount of distance because the Euclidean distance is symmetric. So if we count how many distinct values in this 4 distance matrix, so this is 1. We only need to count the elements in lower triangle or in high triangle. That will be this is 1, this is 2, this gives us 3. So the total is 6. So this is just to verify what we have discussed previously. And this block shows you is a much simple and faster solution to calculate pair distance for a given set of dots by using SciPy, this spatial, this modular. So you can look at this block. So you just need to import this distance matrix function from SciPy special, this modular. Then also import pandas. Then here we define 4 dots in a 2-dimensional list. These 2 lines are used to display these indexes, column indexes and row indexes. Then we can read this distance matrix knows what 2 items are in each distance value. Then we simply, distance matrix is the function from this SciPy special. We only need to pass these dots as a first and second, because we calculate a pair distance, right? This one gives us, we pick from the first set, we pick the second from the second set. That's it. This will calculate this distance matrix. Okay. Okay. So now we have understand this Euclidean distance, right, for 2 individual dots, as well as the distance matrix for a given set of dots. Now we just need to find the closest pairs. If we have a distance matrix of these 4 dots, which can you find if we just read? We can just simply read this distance matrix. We can easily find which 2 dots is the closest. So we just need to find which value is the lowest. Of course, we need to exclude this 0. 0 is the dot to itself. And that makes the closest dots. So we will find this distance is lowest, right? The shortest distance in this case. Then we just need to read the index of column and row. So that will be the dot 3 and dot 2. That means the last dot, right, and the third dot, these 2 dots makes the closest pair in this problem. So this is the logic of this closed pair problem. Now let's look at this script. We have one script on the text page 478. Oh no, we have one script from the text listing 11.3. Okay, so you can go to listing 11.3 to find one solution. Here in this notebook, I'll give you an alternative. Okay, so in this solution, we will first define 2 functions. The first function will calculate the distance of 2 given dots, right? That's 1 pair distance. The second distance will return the distance of the distances for every pair in a given list of dots. So all the different combinations, we will calculate the distance for all the combinations. That's the second function. Okay. In this solution, the distance trooper function will return the distance for all the combination. However, we don't need to calculate all the combination. We only need to calculate this amount of combination regarding their distance. So in first submission, ask you to improve or modify this second function to make it only calculate the distinct distances, excluding all the redundant duplicate distance values. The first function, both functions requires this math, okay, math library, you import math. Then we define the first function given two dots in A and B, these two arguments. Then A and B are two list, one-dimensional list. Then we simply apply this. We first calculate the square terms, right? The square of the difference along each dimension. We will put that into a list. Then we will sum these square terms. Take the math square root. This function will calculate the distance between A and B, these two individual dots. The second function, distance tuple, we will pass this a two-dimensional list, including all dots we want to calculate the distances. Then in this function, we first find the number of dots. Then we will use list comprehension. Then we need to do a nested loop, like what we did in this previous example, right? We did this nested loop. But in this example, we use this for loop structure. Here we write them into a list comprehension as a shortcut. So this one takes the first dot. The second for loop takes the second dot, right? We didn't exclude the duplicate, right? Repeated combination, because here we don't consider the order. Then this part makes the distance tuple for each pair. Because we need to find the closest pair, so we also need to keep track of the indexes, right? Not only the distance, but also the indexes of two dots. So we group these three values into a tuple. The first value is the index of the first dot in this original, right? The dot list. The second value is the index of the second dot. The third value is their distance. We group them into a tuple. The tuple is a Python built-in object besides list, dictionary, and set. Okay, before we use these two functions to find the closest pair, let's test these two functions first. First, we test the first function. We want to calculate the distance between 2 and 5 and 3 and 1. So this is the result, which is correct. Then we test the second function. We take this 4 dots case. Then we simply define these 4 dots, then pass these dots to the second function, distance tuple, directly. Then here we print how many returns. We have 16, right? We have 16 elements in the return. Then we print the first 5. First 5 shows you each element in the tuple contains first dot index, second dot index, as well as their distance. So this one shows you we didn't exclude any redundant distances. This is the first dot to itself, distance is 0. The second tuple tells us the distance from item 0, dot 0 to dot 1 is 4. Okay, so this is the way we read this returned tuple list. Return is a list of tuples. Each tuple represents one distance along with the index of the two items inside. So both functions are correct. Now we just need to write the program which can find the closest pair, right? For the given 8 dots. This is 8 dots. We use the same from the text. we put these 8 dots into a list of lists, 2-dimensional list. Then we will run distance trooper directly. We store this distance troopers into TT. Okay, TT is a set list of troopers. One element is one distance. Then we need to extract all distance value from troopers because each trooper contains 3 values. We extract the distance from this trooper, put them into distances, this one-dimensional list. Then we need to find the shortest one, right? Shortest one. And here, don't forget, because we didn't exclude this 0 dot to itself distance from this distance trooper function. So when we find the shortest distance, we must exclude 0 from this distance list. So we have this if d above 0, this condition. Then we will iterate every distance value to find the minimum one. So with the shortest, with the minimum distance, then we need to find which pairs has the minimum distance. This line will do so. So here we also use this shortcut. So here you can read this shortcut as we will first if d, right? So here we first take ABD, this TT is a trooper, contains 3 values. We first we iterate this trooper, a list of trooper. Then for each element, A is the index of first item, B is index of second item, D is the distance between them. Then we will iterate every element from this tuple. Then if D is equal to the shortest value, then we will include these 2 indexes into this list comprehension. We have to repeat this for every values in this, for every tuple, because we may have some pairs having the same distance. We may have more than one pair having the minimum distance. So we have to iterate over every element. So then we write this list comprehension into a new variable, nearest pairs. Then the last 2 lines will print the nearest pairs, print the indexes of the 2 items in each nearest pair. Here the result shows you actually we get 2 pairs. However, these 2 pairs are identical except the position are swapped. So this is not necessary. We can reduce this only to 1 pair. We only want to know the dots regardless of the positions. So this is the current script. What you want to do is I want to modify this distance tuple function. So we don't calculate the distance between the same dots if 2 items in a pair are the same dots. So when first item equal to second item, we don't need to calculate distance. Also, when the 2 items are distinct, we only calculate 1 distance for these 2 items, 2-item pair, regardless of the order of the selection. Yeah, no matter you select the first item first or second item first, we only calculate distance once for these pairs. Then we can get rid of this duplicate distance values in a distance matrix. And at the same time, we don't need to apply this filter. We don't need to apply this filter because all the distance will be above 0. So this is the first submission. Then submission 2 and 3 is not required. I will not grade them. You can try yourself. The following part is supplementary. It's just a little bit more information from the linear algebra perspective.